Lesson 4, Trigonometric Identities. You can use the identity sine squared x plus cos squared x equals 1 that you learnt from year 1 to prove two trigonometric identities that you'll need to remember throughout the course. If we start with the expression 1 plus tan squared x, we can rewrite it as 1 plus sine squared x over cos squared x. Now let's make a common denominator of cos squared x. So we get cos squared x over cos squared x plus sine squared x over cos squared x, which gives us sine squared x plus cos squared x over cos squared x. And we know sine squared plus cos squared is 1. So this is 1 over cos squared x, which is 1 over cos x all squared. And 1 over cos is sec, so this is sec squared x. And so 1 plus tan squared x is equal to sec squared x. And that's the first of the identities that you need to know. This time let's start with the expression 1 plus cot squared x, where cot is 1 over tan. We can rewrite this as 1 plus, because tan is sine over cos, this is going to be cos over sine. So it's cos squared x over sine squared x. And now this time let's make a common denominator of sine squared x. So we get sine squared x over sine squared x plus cos squared x over sine squared x. And let's simplify, we get sine squared x plus cos squared x like before, this time over sine squared x. And so sine squared plus cos squared is 1 over sine squared x, which is the same as 1 over sine x all squared. And 1 over sine x is cosec x. So this is cosec squared x. And so 1 plus cot squared x is equal to cosec squared x. And this is the second one that you need to remember. Let's do an example. Given tan theta equals negative 5 over 12 and that theta is obtuse, find sec theta and sine theta. We know that 1 plus tan squared theta is equal to sec squared theta. So sec squared theta is equal to 1 plus negative 5 over 12 squared is 25 over 144. And so we get 169 over 144. Taking the plus minus square root, we get sec theta is equal to plus or minus 13 over 12. If we draw a cast diagram, because tan theta is negative 5 over 12, we draw a line with a gradient of minus 5 over 12 going through the origin. So it'll look like this. We know theta is obtuse, so this is acute and this is obtuse. So we're looking here, because we want sec theta is 1 over cos theta, so we're looking at cos theta. Here, cos will be negative because we're going in the negative direction. So if cos is negative, sec is negative. So therefore, sec theta is equal to negative 13 over 12. Part B, we know that tan theta is equal to sine theta over cos theta from year 1. And so rearranging, we get sine theta equals tan theta times cos theta. Tan theta is minus 5 over 12, and cos theta is 1 over sec theta, because sec theta is 1 over cos. So we're going to times by the reciprocal of this, which will be minus 12 over 13. We see the negatives cancel and the 12s cancel, and we get 5 over 13. Let's do another example. Let's prove that sec squared theta minus cos squared theta is the same thing as sine squared theta multiplied by 1 plus sec squared theta. For these type of questions, you can either start from the left-hand side or the right-hand side. For this, I'm going to start with the left-hand side. We start with sec squared theta minus cos squared theta. We can rewrite sec squared as 1 plus tan squared. So there's going to be 1 plus tan squared theta. And we know cos squared theta is 1 minus sine squared. So we're going to rewrite it as 1 minus sine squared theta. Now this, the 1 and the negative 1 will cancel, and so we're left with tan squared theta minus negative sine squared theta, so it's plus sine squared theta. Tan theta is sine theta over cos theta, so this is sine squared theta over cos squared theta plus sine squared theta. And we can factor out the sine squared theta because it's in the numerator and it's here. So we can get sine squared theta multiplied by 1 plus 1 over cos squared theta. And we know 1 over cos squared theta is the same thing as 1 over cos theta squared. 1 over cos theta is sec theta. So this is sine squared theta multiplied by 1 plus sec squared theta as required. Let's do one last example. Let's solve 4 cosec squared theta minus 9 equals cot theta for the range 0 is less than or equal to theta, which is less than or equal to 360 degrees. Cosec squared theta is 1 plus cot squared theta. So we can rewrite this as 4 times 1 plus cot squared theta minus 9 equals cot theta. And by expanding and rearranging, we can get 4 cot squared theta minus cot theta plus 4 minus 9 is minus 5 equals 0. We want to make it into cot theta because it's the linear term and this is a quadratic. So if we want a quadratic in terms of cot theta, we can solve it like this. So we can factorize this, or you can make a substitution as y equals cot theta or etc. So we can factorize this to 4 cot theta minus 5 multiplied by cot theta plus 1 equals 0. So cot theta is either 5 over 4 or negative 1. So tan theta is 1 over cot theta, which is 4/5, or tan theta is equal to negative 1. Let's solve them separately. For tan theta equals 4/5, using your calculator, you can get theta is equal to 38.65980825, and so on. And because it has a period of 180 degrees, you can add 180, and you get your second value as 218.65980883, so on and so forth. So they are around 38.7 degrees and 219 degrees to 3SF. For tan theta equals minus 1, your calculator will give you theta equals minus 45 degrees, but that's outside the range, so let's add 180, and we get theta equals 135 degrees, and we can add 180 again, and it will still be in the range, and we get 315 degrees. And so therefore, theta is equal to 38.7 degrees, 135 degrees, 219 degrees, or 315 degrees, where these two are to 3SF. And that is it.